Hello everyone. Today we will be examining a cross-section of a shell and tube heat exchanger. This video is mainly for beginners, so we will start with an introduction to computational fluid dynamics, or CFD. In essence, CFD is the prediction of fluid behavior and properties such as pressure, velocity, and temperature at specific points through numerical methods. These methods primarily utilize Navier-Stokes equations for fluids, which is a set of partial differential equations. While the description of this is beyond the scope of this video, all you really need to know is how these types of equations are solved, which is by considering finite differences. So, for example, if I told you to walk 1 meters per second for 1 second and then run 0.9 meters per second for another second, then the total distance you traveled would be 1 meter. We solve for distance by breaking up the time into intervals for a variable velocity. Now we can do this for infinitely small intervals to solve for difference, given that velocity is constantly changing. CFD does something very similar to this, except we replace this time interval idea with an interval over space, and the equations are more complex. Some partial differential equations can be solved analytically with exact solutions. As of yet, solutions for most instances of the Navier-Stokes equations are not defined analytically. In fact, the mathematicians do not understand it too well, so much so that the existence and smoothness of the solutions of the Navier-Stokes equations is a millennial prize, offering $1 million to anyone who can prove or disprove it. Alright, that's all the mathematical background you need for this video. The concept of finite differences is how we break up the geometry we make into smaller pieces to find the properties we are interested in. The smaller we make the pieces, the more accurate the solution will be. Now, what are some of the applications of CFD? Basically, the applications are endless. Anything involving fluids can be simulated in CFD. Pumps, cars, planes, air conditioning systems, and more can be done in CFD. For our problem, we will be discussing heat exchangers, which are used in most industrial plants for condensers or evaporators. Designing these is a very important problem for saving money and making power cheaper for everyone. Now, let's get into it.
Once you have your Workbench 18.2 opened up, double-click on Fluent. Now, while the project itself opens up, you're going to click on Geometry, go towards the right ribbon, and over here where it says Analysis Type, you can choose between 3D and 2D, but for this video we'll be sticking with 2D just for simplicity. Once you have that, you left-click on Geometry, right-click on New Geometry. Now this is where we'll begin the overall sketch. You can choose between different planes as well as different surfaces. But for this we'll be choosing the XY plane. But before we do that, we have to establish a grid and also major and minor spacing. This can be done under the Settings tab. Under Grid, check in for both boxes. Change major grid spacing from 5 to 1, minor space per major from 5 to 10. Now we're ready to begin our sketch. Now as you can see here, I selected the blue arrow, which oriented me towards the XY plane. Whenever you begin a sketch, you can choose whichever plane you would desire. Now, after I choose the XY plane, over here on this little icon, this is where you design a sketch. Now here's where you can draw, modify, add dimensions, and also constraints. But for us, under Draw, we're going to choose Circle, go from the center and drag out and click to where you want to end the circle. You're going to click Rectangle, click and drag. Now you see here, this rectangle is oriented differently from the one I drew previously. Now as you can see, I right-clicked and pressed back, and it deleted that rectangle. And you can do this for any geometry that you draw. Now after this, over here on Dimensions, you can sit here and say how you would want your lengths oriented. Okay, here on the bottom shell and tube, and the top as well, where we're going to have the in and outlet tubes, you have to delete certain segments. So you're going to choose Modify and Trim, and you're going to choose the segments that you want deleted. Now you can see here that all of it is lined up as blue, which is how you want your primary sketch set up. If it is not blue or yellow, then you messed up somewhere along the way and need to take a look back. Now you can see here I drew several tubes for the heat exchanger. But now here, when you draw the circles, for simplicity while drawing it, you can see here on the circle where it says R. This keeps all the circles the same radius or diameter. That way, whenever you're setting up your dimensions, you can only change one circle and it'll change the dimension for all of them. And here I'll be showing you the distances that I preferred for this model. For length and distance, you're going to click the beginning of the length and all the way down to the end. And as you can see here, it starts showing you the lengths. Now you can see here that I drew the rest of the tubes and that the size has changed. Now I wanted to show you, just as an example, all these are going to change at the same time. Now I'm going to go to the length that I set up for it with the diameter. As you can see right here, which is D14, is 0.15, but let me change it to 0.25 real quick. Now you can see that they increased in size all at the same time and they're all equal. But for this we're going to keep it at 1.5 just to get some spacing for this heat exchanger. Now after this, you're ready to set up your sketch from, or your surface from a sketch, sorry. You're going to go to Concept, Surface from Sketch. You're going to select the sketch that you want. Now you see here, all this is highlighted yellow. All of it has to be highlighted yellow in order to make your surface sketch. Click Apply and Generate. And once it is all gray with a blue outline, that means you set up your geometry the correct way. Now zoom out to show you the rest of the dimensions here. Now we're going to go back towards the main project here. You can see that with the geometry we have a green check mark. This green check mark means that everything is correct and you're ready to continue to the next step for your analysis. In my opinion, every time you are done with each step, save it, just in case if you have to leave or shut down your computer or if you forget to plug it in. You select the file that you want it saved and you name it for whatever you want. I named this one Shell and Tube 2. Once it's done saving, you see under Mesh it has 2 green arrows, which says that you need to work on your mesh or establish a mesh in order to continue the analysis. Now once your geometry is set up, you can see here it is the same. And in the top ribbon right here, you have certain selection options ranging from the corner to the edge, or the face, or the whole object in general. Now select the edges all simultaneously. You have to click one edge, press Control, click on the next edge that you want, and Control again, and continue the process till you select all the edges that you want. Now what I'm doing now is creating a named section. Now the reason why we create named sections is to help you during your solution phase. Click Control, click Control, click Control. Right click, create named section. For this we're going to name it the Shell and Tube Walls. After that, click OK. You can continue the same process for the tubes as well as the inlet and outlet. Over here on the left ribbon with the model tree, I have 4 named sections here. Now here what this red box indicates alongside with the red arrow where the named section is at. But as you can see here, I missed a section along the edge. Now this is no problem at all. You go simply back to geometry, and to continue off of what you selected already, you press Control again and click on what you want to add on and select Apply. After that, now you can see everything that you want is in red, which is what is marked as a name section. And the same for the tubes. And just for safe practice, always go over your name sections just to make sure that you have everything selected the way you want to. Now to set up your mesh, you click Mesh. Now when you select your mesh, you can choose between corner, edge, face, or the whole object. For this, we're going to choose the face option, go to Method, click on the whole geometry itself. After that, you're going to go to Geometry and click Apply, the same thing as we have done with the sketch as well as the name section. We're going to change this to triangles and update. After every time you issue a mesh command, click Update. That way it'll show your mesh. Now as you can see here, this designs a mesh. Now the purpose of the mesh is to have a more accurate solution on your project and your model. And the rule of thumb is that the tighter the mesh, the better the mesh, as well as the better the solution. For this, we're going to change the smoothing to high and the revolute center to find. You can find these under the left ribbon under the details of mesh. Now you can see here, after we've updated the revolute center as well as the smoothness, the mesh is tighter. So what I just did now was select mesh control, but I selected sizing and selected the face again. I changed the element size to 2.0 e to the negative 002 and changed the behavior to hard. And as you can see here, the mesh is even tighter. And through trial and error, as well as long as you gain experience throughout this software, you will learn how to make your sizing better. Now to select, for tubes, we can select multiple ones. The same process as we have for a name section. Control click, control click, control click until you select all that you want. Apply. Now for this, we're going to change the element size to number of divisions. And we're going to change it from 1 to 120. And then the behavior to hard. Now over here under bias, you can select the pattern that you want for it. But for this, we're going to keep it all uniform. Click Update. And then you go to Mesh. And I see around the tubes we have a dark circle around it. That is the mesh around the tubes themselves. And see here, you could change, and if you want to go back and change your number of divisions to element size, you can go back, select the mesh command, and change to whatever you want. For example, bias, number of divisions to element size, so on and so forth, as well as the number of divisions that you want to place on there. If you wanted to change it from 120 to 4 or 400. Now if you look in here, it is still not as tight as we would like for the mesh. So what we're going to do is refine it. What refinement does is it makes the angles as well as the lines of the mesh sharper and much more compact. Now when you refine, you want to keep it in between 1 and 3, but generally 2 is the best option. If you choose 3, your solution will take longer in the analytical process. After it's done updating the mesh, you click on mesh every time you issue a mesh command to see the difference that you have made. Now after I have refined this mesh, you can see that it is much darker and much more compact. And now this one is just for fun. We're going to do the same thing towards all the sides, including the inlet and outlet, excluding the tubes. And we're going to do this under Mesh Control, Sizing, Control Click, Control Click. But as you can see, I forgot to change from the face option to the edge option, so I can go back and change it. Control click, control click. Now the entire outer shell of this heat exchanger has been selected. Change element size to number of divisions, change it from 1 to 120, behavior to hard. Click Update. Now as you establish more mesh commands, every time you update your mesh, it will take a little longer just because it is taking the process power. Now as you can see here along the inlet and outlet, it is much more darker than it was before we established this edge sizing. And now this looks good enough. We're going to continue to the solution phase.
So going back to the dialog box of your Ansys study, we're going to go to Solutions, click double precision, parallel, and choose 4 processors if you have a quad-core processor. Any other processor, you might need to choose less. So I'm just waiting for the mesh to load because it might take a while if it's very fine. You'll get some errors if anything is wrong with it. You might need to go back and change your mesh. See, so for this one we're going to be doing a steady flow, but you can do transient. Transient means it will change with time for your velocity. We go to models, go to the energy equation, click it on, and then we go to viscous model, and we want to choose K epsilon method. Click OK. Go to Materials, click on Fluid, opens up the Arid dialog box. Now you may want to choose a different fluid, or change the material properties of the fluid you're considering. So we can just click it and change it here, like we did with density. We go again, we can change it. We can change the name, or open up a different database. So for this study, we're going to choose water. Click copy. Should be showing up right there, and then you click change create, and then close. Go into our boundary conditions. We need to set what is going to be our inlet and outlet. If you name the selections correctly, the inlet should already be an inlet. Ansys recognizes this, and so we can change the velocity magnitude. Here we're going to change it to 25 meters per second, and change the temperature to about 400 degrees Kelvin. Click OK, and then now we can look at the other boundary conditions, look at outlet, the wall temperature. We're interested in changing that, so we're going to choose temperature for our thermal, and then change the temperature to about 225 Kelvin. Going to methods, we can change our method depending on what exactly we want or how accurate it can be. Here we're going to choose second order upwind for everything besides the pressure, which we're going to choose as standard. It really just depends on what exactly you want to do in Ansys. Click on initialization. You want to choose standard initialization, and we want to compute from the inlet. You should see the x velocity as that which we chose for the boundary condition. Click initialize, and on the bottom right corner of the console you're going to see some action going on, and it'll show you when it's done. Go now to calculation activities. You're going to want to go to solution animations. The dialog box should open up, and over here you can choose iteration or time step depending on what object you want to animate. And we're going to create a new object, a contour, and we're going to choose a velocity contour and fill it, save display, and it should show up on the right. Click close. Now click this, and then click OK. Now the animation is ready to run. Now you can go and create another animation, new object, contour, filled. This time we're going to choose temperature, save display. It should display on the right. Click close. Click the object you just created and click OK. And they should be appearing on the left. We can create yet another one. This time we're going to do pressure. Fill this one, save and display. Really, you can change the options however you want to. So we can turn this off and it will show, and it will not be filled this time. So click close again. Click the object you just created. Now click OK. Run calculations. So the number of iterations basically means it's going to run a set amount of times. The more iterations it runs, probably the more precise it's going to be, but the longer it's going to take. So here we choose 500. And you want to check to make sure your animations are all correct. You can always go back here, but it's really important to go back right before you run it, or else you're going to have to redo everything. Again, we're just trying to make sure everything is done correctly. Going back to run calculation, we can click calculate and it will start running and solving for the solution. It may take a while depending on how fine your mesh is. Generally speaking, the finer your mesh, the longer it's going to take, but if you want to redo it to check the convergence of your solution to make sure it's correct, you can refine your mesh after you get your initial solution, and you can compare it to the solution you ran previously and see how close they are to know exactly how accurate it is. Okay, looks like it's done. Going back to the console, it's important that the solution converges. If it doesn't converge, you might get an error. It might be a problem with your meshing or your geometry in general. Like sharp corners are generally difficult to produce in Ansys because you have to do really fine meshes. Okay, now going back to playback in the results section, we can look at the animation that was just written. So looking at the different windows, we see the results. And clicking from the format, we can write an MPEG file onto our computer. Click Write, and it will write the animation on our computer in an Ansys file created under the same name. And it might take a while, it might not respond, but as long as the cursor is still loading, it still shows that it's loading, and you're okay. Don't exit out. And frames red, that means it's done. Yeah. As you can see, that's the file name right there, so that's what we're looking for when the MPEG file is created. So going into our computer, looking for the specific file name that we created that's associated with the Fluent. So chillin tube 2 is what we created, so we're looking for that. Clicking on this and going to DPO, FFF, Fluent, the animation should be there. Clicking on it, playing it with whatever media player you generally have. Here we just use Windows Media Player, and it should pop up. And this is also where your other one should be too, if you had any more animations. This is the non-filled pressure contour. It looks remarkably different from the filled one. It just depends on how you change your options, what you're looking for. Specifically, this is the pressure contour. As you can see, there's a lot of action going around the cylinders or the tubes of the shell and tube heat exchanger. And in terms of meshing, what we'd want to do is try and refine around that area to make sure the meshing's really tight, because there's a lot of stuff going on there. And this is the temperature contour, as you can see. And that's basically it.
So from this video, we can conclude that using Ansys, we can solve problems from using computer fluid dynamics in all areas of the engineering field, such as aerospace, automotive, biomedical engineering, and also finding velocities of fluids in pipes. Thanks everybody for watching this video, and I hope that it was very educational, and thank you for watching.